Hi, everyone. I hope you're doing well. And welcome to this series of Azure Development. So, very quickly, I'll just elaborate. We are starting our journey with Azure Development, the complete Azure Development series. Um, and this is the zeroth module. It's not even the first module, it is going to be the zeroth module of our, whoops, it is going to be the zeroth module wherein we'll be talking about the basics of cloud. Again, if you already are familiar with how cloud, especially Azure, works, you can definitely skip this module and move forward with Azure development. But if you're somebody who is just a developer, you're trying for the first time to move towards cloud development or Azure development, and you are kind of stuck because there's a part of you which is saying, start with the basics, and then there's a part of you again who is saying that you should directly start with the Azure development side. Um, so this actually caters to both the cases. Okay, so this module is gonna serve you the purpose of knowing the basics, and then from next module on, you can directly start with the Azure development. Okay, so this is zeroth module, just created so that you can get to know what exactly are the basics of cloud. Again, this is everything that you need to know before starting your journey with Azure development, cloud development. Also, so when I say Azure development, I'm pretty much talking about AZ-204. Okay, this is the certification exam by Microsoft. If you're aiming for this, okay, and you're like, okay, I need to first do AZ-900, that's the foundational one, and then only I can come to AZ-204. Well, partially it's yes, but then the way I'm creating the playlist here is so that you can actually quickly just look at this video, get all the basics that you need, and then directly move on to Azure development or AZ-204 from the next module onwards. Okay, so there are going to be 12 modules total. Okay, and all 12 will belong to Azure development, that is AZ-204. But zeroth module I'm deliberately creating for those people who are not comfortable with Azure or who have not actually gone ahead and done something, any of the foundational course like AZ-900 or any of the fundamental courses you've not done, you've never worked with it, it's the first time ever. So this is especially for those people. So again, repeating the same thing. If you feel you know the basics, feel free to directly move to the first module onwards. Okay. All right, great. So let's get back. And here, let's try and start with module number 0, which is Cloud Basics or Azure Foundation. Okay. Now, again, I would like to make it very clear. This is not specifically related to Azure because the cloud basics is going to apply to all kinds of cloud providers. If you talk about Azure, if you talk about AWS, if you talk about GCP, or lots of other cloud providers are also there. If you talk about them, yes, this module is going to cater because it's the basics of it. Okay, so every cloud platform pretty much works the same way. They pretty much leverage the same sort of strategies. So that is going to be common in every one of them. So this module is like that. So don't think that it's going to be very much, pretty much specific to what Azure is all about. No, it's going to be specific to, I would say it's not specific to anything at all. It is going to be catering to all kinds of cloud providers out there. All right, so let's begin with the first fundamental understanding. And again, before I proceed, I just want to make it very clear that this basics module is pretty much everything you need to know before you deep dive into, I would say, Azure development or AZ-204. If you're trying to crack an interview or you're trying to, there's a new role which is asking you to get into this Azure development role, and for that reason you want to kickstart your journey, but then you're stuck between this loop of, I don't know the basics, or should I directly start. So this is the module that is going to contain pretty much everything that you need before you get started with AZ-204. So I have collated all the important things here. Okay, trust me, there's nothing more that you need to know. So don't think that there's something more that I'm leaving it out. Yes, whatever I've left out, I'm telling you by experience, it's not required, it's not mandatory. Stay with me. This is all you need to know before kickstarting your AZ-204 journey. All right. So let's start with the first question. What is cloud computing? So again, I'm taking a lot of scenario examples here. So let's imagine that it's 2001, okay, and there's a guy called Ashish who has started his own software company. So eh, now it's 2001. So the first thing he might want to do is he wants to host his website on internet so that people all over the world could access it. I mean, that's pretty straightforward thing, right? He has to first host that website, only then others could actually go ahead and access it. So this guy is pretty much trying to deploy his website over the web so that others could access it. But now the problem Ashish is faced, that this guy is Ashish, okay? Ashish, this guy now is facing a problem because he has to first buy those heavy racks and heavy servers, and he has to install it in his own company premises. So that's what I'm saying. But now he has to first buy those heavy racks and servers in his own company premises, right? And that requires money, right? Again, you must be thinking, why doesn't he just go ahead to something like GoDaddy or something? But remember, we're talking about 2001. We're talking about the late 90s. There, this concept of have deploying your websites and everything to a third party provider was not a thing actually. So there, he has to actually buy those servers and racks and install it into those premises of his own. Only then can he successfully deploy and host his applications, right? So I think that's that pretty much should make sense to everybody. So that's the biggest problem here with Ashish. This guy has to first go ahead and buy everything. Only then he can just install it. Only then he could deploy his website, and that's how his website would become reachable to everybody on the web. So now Ashish is facing series of problems, right? So now starts series of problems. Problem number one: setting up servers requires a lot of upfront investment. So if you notice, he has to first, like I said, he has to first set up the servers and racks, but that is not going to come for free. That requires investment, or there's a financial word for it called capex. Capex stands for capital expenditure. There's a, I mean, see, if you're not getting hang of this word, that's totally fine. Just know that there's something called as capex. It simply means upfront investment. Okay, so this guy has to go ahead and do some sort of upfront investment. Okay, he has to invest some money. Only then he can go and buy those expensive racks and servers, and then he could install on his premises, and then he could host his website on those racks and servers, right? So first problem is a lot of money is required in the very first place, right? So that's the first point, first problem, I would say. Now the second problem is he needs to have a proper office space that can be dedicated as a server room. So if you notice, um, office space is also required. So even though he has got, like, let's say he's ready to make the money investment, but then ultimately, even if he's able to buy all those racks and servers, ultimately he has to install those into his premises, and that requires some great amount of space as well. I mean, if you've seen your universities or colleges, they have pretty much small, I would say, small server rooms. But then if you talk about enterprise, um, uh, corporates, they might want to have, I mean, higher capacity servers and racks, and that might require larger capacity spaces, right? So for that reason, even that is a problem. I mean, just imagine Ashish is just starting his own startup and he doesn't have that kind of money to rent a huge space on his own. So let's say he's just set up a small office in his garage, and that might not cut the deal, because now he doesn't just want to have money to buy those servers, but also he needs to have that space to accommodate and install those servers. So that's problem number two. Now the third problem is, see, third problem is he has to hire admins and network engineers and pay them huge salaries. Just forgive the spelling mistake, to constantly monitor the server rooms. See, understand, server rooms So let's say he has got the money. Okay, now he has bought the servers. He also has got the space. He has installed all those things in that particular space. But now Ashish also needs to have a system in place so that those servers that have been installed, they can be very easily, they can be monitored 24 times 7, right? They have to keep monitoring the servers, because if it goes down, what's the point of hosting a website in the server if the server itself is down and there's nobody to take care of it? So we need those, admins and network engineers to make sure that the server is completely up and running. Most of the times it's up and running. Okay, also there'll be certain patching and certain maintenance that has to go through. Again, this will be done by admins and network engineers. So Ashish can't do all of that on his own. He has to go ahead and hire these admins and network engineers, and they will actually do the maintenance. They'll make sure to keep the servers up and running and neat and tidy. So for that reason, Ashish needs to hire these people. So as you can see this image, okay, and this is Ashish basically, and he's trying to shortlist profiles to go ahead and interview them, and proceed with hiring. So that's the third problem. Can you see, like, I mean, up until this point, there's lots of problems you face. Like, first get the money to first buy the servers. That's the biggest problem on its own, and that too upfront. Then go ahead and have an office space as well, because you need to ultimately, put everything in that particular premises. And third problem that we've seen is actually you have to go and, Hashish has to go ahead and hire these admins and network engineers, and he has to pay them huge salaries to constantly monitor the server rooms. So now let's look at so yes, that's not the end of the problems. There are more as well. Now the fourth problem is, if the traffic increases for a certain sale, he has to add more servers to handle that traffic. I mean, see, think about this. Let's say there's a Diwali sale, okay? And let's say Ashish is pretty much building an e-commerce, okay? So we know that in e-commerce, when there is certain sale going on, it's very natural that it attracts more and more traffic. So if it attracts more and more traffic, the problem is the current set of servers and rack that Ashish is having in the premises, that is not good enough to to manage the incoming traffic, because now there's a sudden spike in the traffic. Previously, if it was 1000 traffic per second, now it's somewhere close to 4000 traffic per second, and this current set of infrastructure is not good enough to support this kind of incoming traffic. And for that reason, you know what Ashish has to do? He has to go ahead and place an order for one more existing. So let's say set of a couple of more racks, and then he has to again make some more investment, and then that rack will come. He has to again go ahead and settle those racks in his own premises again. So if it was just rack one, now it's going to be rack two as well, right? And now the problem is this sale was only for like 4 days. After 4 days, even Ashish knows that the traffic is going to go back to the normal metric. That is from 4000 traffic per second, 4000 requests per second, back to 1000 requests per second. And for that reason, whatever investment he has made on rack number two, again, millions of dollars of investment. That was done just for 4 days. Do you think it's a wise decision to do that? The answer is no. It's because after 4 days, this R2 will be idle, and that is called underutilization of the resource. So he has put up so much of money just so that his website could be supported in those high tension times of sale period. But then after that, that rack number two will be completely unallocated because it's not required, right? R1 is sufficient enough to support all the incoming traffic. So that is again a problem. So that's what I'm saying, that if the traffic increases for a certain sale, he has to add more servers to handle that traffic. But later, once the sale period is over, he would not be requiring that extra server, and hence it will result in underutilization and wastage of money. So I hope you got the fourth point as well, that it's the problem is, you are putting in the money, but then for 4 days if you look at the trade-off, you evaluate the trade-off between the amount of money you're investing and the amount of ease it's bringing to your business. The trade-off is not worth it. So I wouldn't say it's a bad option, but if looking at 2001, it's clearly a problem because now it's pretty much easy. There's cloud, but back in the late 90s and early 2000s, there was no cloud. And so it was very difficult for these business owners to manage high traffic scenarios because they had to do everything on their own. So that was again a problem. Remember, we are still in 2001, okay? Now, fifth problem, maintenance. Now, maintenance is completely Ashish and team's responsibility. Server patching, update has to be taken care by Ashish's staff. So again, I've already told you that now you may say that this guy has hired admins and network engineers for what? For this maintenance only. But that's the point. If let's say he has hired four people, now these four people have the responsibility to ensure that the website of the company and the servers and racks, whatever they have actually installed, is 100% up and running always, and there's no downtime faced by anything that's deployed. It is all responsibility of these four people. So when I say maintenance is completely Ashish's and team's responsibility, I mean that if something goes wrong, no, they can't put the blame on anybody else. It's their team, their company. Ultimately, they are at loss. So maintenance is not somebody else's responsibility. Maintenance is completely Ashish's and his team's responsibility, right? So things like server patching, update has to be taken care by Ashish and staff. So it is completely his responsibility. I mean, I don't want to jump directly to what cloud is, but if you look at cloud scenario, public clouds, uh, maintaining servers, maintaining racks, making sure there's always up and they're always up and running is not our responsibility as customers. We can always point our fingers at Microsoft, at Amazon, at Google, and say that what, your things are not working, you're violating the SLA, and they will be the ones fidgeting over us. But in this scenario, 2001, Ashish doing everything on his own. It is completely his responsibility. He can't put the blame on somebody else because his team and his team only is responsible to maintain and update and patch and whatever with those set of servers, right? So maintenance is again an overhead. You can't say that that's not a problem. That is a problem. Maintenance is a huge problem actually, right? So by looking at these five problems, first, setting up servers, and that requires upfront great deal of money. Again, it requires a great deal of money. Let me not make it an understatement. It's really something that it's a decision that if you don't have great kind of funds, you don't have venture capitalists with you, you won't be in a position, especially if you're a bootstrap business, you won't be in a position to actually put up money, that kind of money to first go ahead and buy upfront the servers and everything. So first, that's the problem. Second, having an office space was a problem. Third, hiring admins and network engineers and pay them huge salaries to constantly monitor the server rooms. Again, that hiring is a challenge. Fourth, the traffic increases for a certain duration. You've got to ensure that your website is not down, and for that you need to again buy more infrastructure to support your business. But then what happens later when the sale is gone? You're back to your normal traffic, and that makes it like literally a waste of money plus underutilization of the resource. And fifth problem was the maintenance problem. You know, uh, they have to completely do on their own. There's nobody that they can point their fingers to. So these are the problems faced by Ashish, and this is where Ashish becomes overwhelmed and he decides to quit his startup. So this is where we discuss the journey of Ashish, how he started, and what all challenges he faced, and that got him pretty much overwhelmed, and finally that made him quit his startup, right? So again, a pretty sad story, but that's how things have gone through actually with Ashish. Now we will look at a flip scenario on fast forward to today. If there's an entrepreneur, there's a company, there's a startup, there's a community who is trying to build themselves up, if they face the same set of challenges, how would they respond now in 2023? Okay, so yeah, as you can see, Ashish said I quit and he closed everything down. But now Ashish goes ahead and calls his friend, okay? He calls his friend Ramesh, And he tells him his entire story, like what happened, how he decided to start a business, but then what problems he faced, and because of that, he decided to quit. That's what happened, right? Now Ramesh is right now he's listening very carefully, okay? And right now Ramesh works at Microsoft. And after listening to this particular story, what Ashish told to Ramesh, Ramesh is working at Microsoft, is an employee at Microsoft. Now, Ramesh realizes that this is a large scale problem. What is a large scale problem? It means it's a problem that has the potential to be faced by not just one business or two businesses. It has the potential to be faced by multiple businesses. There could be so many entrepreneurs and startups that could face the same problem and they could quit for the same reason exactly. Now, Ramesh realizes that this is a large scale problem which sooner or later will be faced by so many startup founders, right? That's what Ramesh just gets this epiphany. Now he takes this problem to his team at Microsoft because remember, he works at Microsoft. Now he says that, you know what, guys, there is $1 billion market here if we could fix this problem. So he says that there is $1 billion untapped market for us if we can solve this problem. He's talking to his team, by the way. He is talking to his team at Microsoft. He's saying that, guys, it's a problem. It's a very good problem. If we could fix this problem, it's $1 billion industry waiting for us, right? But only if we can solve this problem. S- Now, when he narrates this problem to Microsoft, Microsoft takes this problem very seriously and decides to work on this problem. Okay, now they realize the potential of this problem, and if they could fix this problem, what kind of revenue, what kind of profit margins are they looking at? They realize this, okay, at a very, very early stage. Now, this is where Microsoft decides to work on the problem. Now, what? Now, Microsoft decides that what if we set up our data centers across the world? So, first, what if we set up a so see, ultimately when I say that Ashish had to first go ahead and Ashish had to first go ahead and buy those racks and servers. So when racks and servers are collated in one dedicated room or one dedicated premises, you could call that as a data center in case you have never heard the word data center. Okay, so even you could say Ashish was having a mini data center. So data center is nothing but collection of racks and servers that could collectively, act like deployment servers or something like that. Now, Microsoft said, what if we go ahead? Because see, Microsoft is a strong company. It's a strong company. They already had a lot of money, right? They already had this mindset that, um, we have got funding with us. We have got good revenue with us. They were looking for something like this. And now that they've got this problem, what they're saying is that we will use our money to go ahead and distribute or create, or you say build those data centers across the globe. Like imagine this is the earth. Okay. You talk about Asia, talk about Africa, talk about Europe, all the continents you can talk about. They decided to first go ahead and start building their data centers in each of these continents. Okay. Again, it was just a vision. They could go wrong also. They could lose lot of money. So yes, this was a very courageous decision and it required a lot of leap of faith as well. Right. So they first set up their data centers across the globe. Once the data center was set up, then they said, you know what? Hey, small startups, uh, s- medium scale companies, small scale companies. Hey, everyone, we know that you guys are facing huge set of problems with setting up your own infrastructure, and then having the money to first buy it, then having the premises to set it up, then hiring a lot of engineers to maintain it, then have some space in it, and then ensure that you're maintaining it properly, it's never going down. So all of these challenges you're facing, why don't you let me help us? Sorry, why don't you let us help you guys? So this is where Microsoft came in. They set up their data centers across the globe, and they said that, let us help you. And now these companies said, how can you help us? Now this is where Microsoft said, see, firstly, we are setting our data centers up. We have already done it. So that means if you want to utilize our servers, if you want to utilize our servers, there is no need for you guys to go ahead and buy those servers, because it's already done by us. Why do you have to first go and buy those servers from anybody or from us and then set it up in your environment and then do everything? No, we already have got the servers in our data centers. Why don't we deliver the compute capacity? Now, again, don't get confused. What's compute capacity? It's nothing but you could say, basically, see, whatever these companies ultimately require, all they require ultimately is a compute capacity. Okay. Now, they could get this compute capacity either by setting up their own data centers, and then they could get the compute capacity, or you could get it they could get it from somebody else. But ultimately the whole point of the matter is, they should get the compute capacity is nothing but like RAM and hard drive and compute server, the clock speed and the processor, all of that, because ultimately you care about that thing only. Now it's like you trying to eat a mango. Now, either you yourself cut the mango in different pieces, and then different slices, not pieces, and then you could enjoy each slice, or you could there could be somebody else who could directly give you. Ultimately, the whole point is that you could enjoy the taste of the mango slice, right? Now, it doesn't matter whether you are doing it yourself or somebody else is doing for you. Same here. Ultimately, these companies require compute capacity. If they can set it up in on their own premises, well and good. But you've already seen the lots of problems with it. That's where Microsoft said that we are already setting up our servers. All you need to do is directly just subscribe to us, and we will deliver this compute capacity, all the important server capacity, to you over the network. That means, hey, companies, that means you don't need to worry about setting up these servers. You don't need to worry about having a space to set up these servers. You don't need to worry about putting an upfront investment. You don't need to worry about hiring network engineers and whatnot. You don't need to worry about maintain those servers. Everything will be done by us. You just subscribe to us, and you only pay for what you use. That means if there's a company who needs, let's say, four servers of 8 GB RAM, just an example. After, let's say, 6 months, this company goes bankrupt. Now, all they had to pay was whatever they have consumed in these 6 months. So let's say per month cost of these four servers was coming out to be, let's say, for an example, 50,000. So all they would have to pay was 6 times 50,000, right? Somewhere around 300K. But imagine if instead of going with this approach, imagine if they had set up their own servers and everything. After 6 months, if they were to go bankrupt, who would, like, they have to first sell these things off, and who would buy them? That's again a problem. So that would become like a liability, right? Here there's no liability concept. Here everything is being managed by the provider. In our case, it's Microsoft. Plus, the good part is that it's completely on the subscription basis. That means pay as you go. That means pay only what you have used. If you don't feel like using it more, there's no liability attached. You can directly just say unsubscribe, and you're good. So you only pay for exactly what you've consumed, right? Again, scaling made easy. You remember that sale example, Diwali sale example. Here also, if these companies, they want to enhance their sale, let's say there is certain sale coming up, and for that they require more compute capacity. They can very seamlessly, instead of buying everything again, setting everything again, and then after 4 days, keeping it idle, instead of that, they can simply upscale their infrastructure from the provider for 4 days. So they pay extra cost for those 4 days only. After 4 days, they can downscale again, and there's no cost. They're back to the normal traffic and normal cost. So, see, it's completely win-win for both the people. Now you may say that, how is that? So that's a win clearly for the startups and companies, because see, it's solving all their problems. There is no upfront money needed, no upfront money needed, because they're clearly saying, Microsoft is clearly saying to them that you start subscribing to us, you don't need to set up everything on your own. So why would you need an upfront? We are not asking you to do an upfront payment. We are asking you to pay only for what you're using. Okay, and that too will happen post the post month or quarter, right? So there's no upfront money involved, right? Second, no space problem, because the data centers will exist in our space, not in your space. Because you ultimately care about compute capacity, and we are providing you the compute capacity over the internet. So it shouldn't matter where that data center is. To you, it shouldn't matter unless and until it's extreme sensitive security concern, like government security government agencies. Unless and until you're them, we don't think where data center is located should be a problem to you. So that's one. That's the second problem we are solving. Third problem that we are solving is no need to hire network engineers and admins, because see, we are having our own set of network engineers and admins, and we are completely taking care of all possible measures to keep it up and running. So because you are not having the premises, why would you need them, right? So third, again, you don't need to do any hiring. Upscale, I already told you, like you can very seamlessly tell us that you require to upscale the infra, we'll do that for you. And then whenever you say downscale, we'll do that for you. So no need to, a problem. There's no problem for scaling out and scaling in. And the fifth problem is maintenance. Again, it is completely our responsibility to give you the complete system and make sure it is available. There's a sort of SLA kind of thing called uh, attached to it. But then we'll talk about that later, because I don't think right now it's the right time to talk about SLAs and all. So yes, there is an SLA. No company in the world can guarantee you 100% availability, but there is a guarantee that they give you, okay, and you can take their word for it. So again, the maintenance, how to patch the systems and update the systems, make sure the servers are up and running, is none of your responsibility. You can completely close your eyes and trust the provider. So see, it's win-win actually. It's win for the customers right now. Now you must be thinking, how is that a win um, for Microsoft? So for Microsoft also it's a win, because see, they have already they have already set up they've already set up the servers, right? They've set up the servers. Now, yes, they have made a great deal of investment. I agree. They have made the a great deal of investment. I totally agree with that. But then now they are getting, it's called in there's a term for it. It's called economies of scale. Economies of scale. See, for them, you are not the only customer, or Ashish's company is not the only customer. They'll be having millions of customers using their services. In that case, even though they are not charging a lot of money from a single customer, because they're having cluster of customers, so if you take it as a whole, they are actually getting a lot of money in return. So after few years of this business, they actually you know went profitable. So it's like economies. It's like either I could sell you a product, one person 1 lakh, or I could price the product for 1,000 rupees and sell it to many people. So now there could be more and more customers, because the price is a lot more affordable compared to 1 lakh. So rather than targeting very few customers with very high price range, you could very easily target a lot many customers with a low price range. So that's what the cloud companies actually did, right? So this is one of the I would say that's how it became a win-win scenario. So let's read more about it in my book, or the document that I've written. Now Microsoft decides, what if we set up our data centers across the globe and rent our data centers to these small and medium enterprises? Now they thought this could be a win-win for both the parties. By doing this, Microsoft was solving all the problems faced by entrepreneurs. First, no need to do upfront big investment. That is capex. No need to do any capex. These companies or small companies and startups, they don't need to worry about capex. They only need to pay for what customers are using, which is OPEX, right? This is called OPEX. Like OPEX stands for operational expenditure. CAPEX stands for capital expenditure. So even though customers don't have to pay any CAPEX, but they have to pay OPEX, right? It's not a free community service. They have to pay for what they're consuming, and that is called OPEX. So that means they are only pay for operational expenditure. They don't have to pay for capital expenditure. And the good part is anytime customers can unsubscribe and there's no liability with them. So that's the problem. That's a good thing. Now, second good part. Customers need not have any office space since they will be consuming the servers situated in Microsoft premises, right? So because the servers and data centers will be in Microsoft premises, why should a customer bother about having an office space or having a server space? Now, the third thing, no need to hire admins and network engineers since customers are no longer setting up their own infrastructure. So again, it's pretty clear point that if the data center itself is not with the customer, why would a customer go ahead and hire lots of admins and network engineers? Because they're not even having the infrastructure. Only that party should have these people who are actually, who have that infrastructure. So yeah, in this case, it's the Microsoft which is having all the data centers. And so Microsoft should be the one to hire these people. And again, that's their end of the deal, not customers' end of the deal. So no need to hire admins and network engineers for customers, we're talking. Also, if customers want to scale up and scale down based on peak days, they can very easily do that without thinking about underutilization and money wastage, right? So we already have discussed this that they don't need to worry about underutilization or the money wastage because they could very easily scale out and scale in based on the traffic and scenarios. So yeah, these are some of the great advantages that Microsoft thought of when starting out, right? Now, Microsoft actually does this project of setting up data centers across the globe. So Microsoft, let's say, they were convinced with this idea. They were really happy and they thought it will definitely take off. And so now Microsoft actually does this project. They're ready to do this project and they've done this project of setting up data centers across the globe and providing their services to small companies on a rental basis. Remember, what is that rental basis called? OPEX, operational expenditure. Again, if you're getting confused with the word CAPEX and OPEX, OPEX simply means it's like electricity. Okay. So if you want electricity connection, do you pay for the entire electricity plant of the city? And you pay millions of dollars for that? No, right? You directly start consuming, get a connection, you start consuming, and post the month, whatever things that you have used, whatever electricity units you've used, based on that you actually start you pay for that particular month. So the same way, it's called either call it a rental basis or call it OPEX. So even that electricity model also goes for OPEX model, right? So Microsoft now does this thing. They go ahead and set up the data centers across the globe. They provide their services to small companies on a rental basis. This project, this idea, this whole business unit, so this venture, I would call it, this venture of Microsoft, they decided to call this as Azure. So Azure is nothing but it's a venture of Microsoft that completely deals with cloud. Now again, I'm going to come to what is cloud. Don't worry about it. What is cloud? I'm going to definitely going to cover that. But right now we're just talking about what exactly is Azure. Azure is a venture of Microsoft that deals with this idea of having lots of data centers across the globe and letting small and medium customers or whoever to rent those servers in exchange of money on a rental basis. This venture of Microsoft is actually Azure, right? So I hope that is clear. And this idea to provide all kinds of data center services to customers, especially small companies, over the internet is called cloud computing. So we are looking at what's the definition of cloud computing. This idea to provide all kinds of data center services to customers, data center services to customers. Remember all those customers who are facing the same problem like Ashish faced. This idea to provide all kinds of data center services to customers, especially the small companies, over the internet is called cloud computing. Remember this highlighted word, over the internet. It's very important that you know that all of these services are being transferred from Microsoft to these small companies or startups over the internet. That means companies don't need to worry about setting up their own infrastructure, hiring their own people, office space and whatnot, and maintenance, scale up, scale down, nothing. They can simply fall back to these cloud providers. In this case, it's Microsoft Azure, and Microsoft Azure will provide these services to these companies over the internet. So that's how it becomes a win-win for everyone, right? So I believe, this up until here, it should be making sense. Let's do a quick revision of the things that we have done so far. Okay, so we have seen, we first started with a very simple example of Ashish, how he wants to start his own company. And then once he starts his company, he started facing lots of problems. Setting up the server was a problem, because that required upfront money. Having an office space was a problem. What if he's not having a proper office space? Hiring, he had to hire admins and network engineers to make sure they update and patch the systems always. Traffic, if traffic were to surge up, he had to buy more infrastructure. Now that was again a problem, because later on, once the traffic goes back to normal, those extra resources are for nothing. Then maintenance was again completely his headache. So these were the problems, and then he got overwhelmed. He quit his startup, and he talked about this to Ramesh. And Ramesh, heard this very carefully, and Ramesh realized it's a big problem. He goes to Microsoft. He realizes that, Microsoft, it is a big problem. If we could fix this problem, it's $1 billion market. Microsoft takes it seriously. Now Microsoft decides to go ahead and set up the infrastructure across the globe. Now, once we set up the infrastructure across the globe, we could solve all the problems for these companies. Like, they don't need to now set up their own infrastructure. We'll do that. They don't need to pay upfront money. We don't require that. They only have to pay us what they're using. So that's completely OPEX run model. Now, maintenance is our responsibility. Hiring network engineers is our responsibility. They just have to simply consume the mango, right? So that's the way to look at it. So that's what the story is so far. And this idea, this venture of Microsoft to do all this business, to do this kind of business, is Azure. And this idea and philosophy to provide the data center service to customers, especially small companies, over the internet is called cloud computing, right? So this philosophy is a cloud computing. Cloud computing means that it's I'm this one vendor. I want to provide my services to you over the internet. You don't need to worry about paying me upfront. You don't need to worry about setting up your own. You don't need to worry about hiring others. You simply will start consuming things from me over the internet. And this philosophy is cloud computing. So I think we are good. um, All right. Now we will start. Now there's one. All right. Now there is one more thing that you need to understand as a part of the basics, right? So if you remember, we are doing the basics. Our intention is not just to cover the basics and get you AZ 900 or any fundamental certification certified. No, what we are trying to do is we are trying to grasp AZ 204, which is Azure Development, right? So if you're having a goal to, let's say, crack the certification, or more than cracking, my intention of creating this whole course is not just to crack the certification. There are tons of courses for that. It is actually to give you real-time insights from somebody who's actually doing it right now, the current real-time projects, and to give you all those strategies and techniques and all the concept from the basic till the advanced of what you need to do in order to crack interview roles, especially senior side roles when it comes to Azure development, um, Azure full stack and Azure development. So that's what we are trying to do here. Yes, AZ 204 is 100% covered. Along with it, we are trying to give maximum attention towards um, the interview cracking techniques, right? So that's it's the wholesome thing, and more than that, actually, if you're trying to scale onto this technology because your current, let's say you're not looking for a switch and you're not looking for an interview preparation, you're not even looking for a certification. What you are looking for is you've cracked the current project that you're in that requires you to be absolutely flawless with Azure, and that's what you're trying to do. Again, this is going to be the best bet actually, because um, again, I've got tons of experience with this, dealing with this technology, and I'm going to put everything into this course. So yeah, there's that. Now, as a part of the basic zeroth module, there is one more thing that you need to know. Again, this is the zeroth module. It's not even the first module. If we are just doing kind of, it's like a filler, okay? So for somebody who doesn't know the fundamentals and the basics, directly wants to go for AZ 204, this is just the filler that you're supposed to know before starting out AZ 204 journey. Again, reiterating the same portion. If you feel you're familiar with the basics, you know everything, then no need to watch this video. You can just skip it. Okay. All right. So the next thing that we need to 100% know before moving forward is actually something called as delivery models. Okay. This is common in all kinds of cloud platforms you talk about. You talk about AWS, GCP, or some other cloud platform like, of course, the Azure and Alibaba Cloud, Salesforce, whatever. This concept is going to be there steady in every cloud platform that you talk about. So if you notice, delivery models in cloud computing. There are three fundamental delivery models in cloud computing. All the services in Azure can be categorized into these three fundamental delivery models. Now, the reason I'm saying fundamental delivery models, it's because these days there are lots of newer kind of delivery model categories coming up, like function as a service, like it's so many things, right? So, but fundamentally, these are the three. Okay, and we'll talk about these three in depth, right? So these three are infrastructure as a service, platform as a service, and software as a service. Again, what is delivery model? See, the way I'm I might have put it across right now is that delivery model, there are three delivery models. But what exactly is a delivery model? You know now what is cloud. You know what is cloud. So cloud, what was the official definition we studied? Delivering of all kinds of computing service, database service, DevOps service, or like networking service, any kind of, basically any kind of compute service, storage service, any kind of service that you are getting from an external vendor, right? You're not having your own data centers to get these services. You are relying on an external vendor to get delivered with these services over the network. These services are being transferred to you over the network. That means you're not required to actually set up the data centers, to manage the data center, have the space, have the network engineers, make sure it's always up and running. No, you are getting it from elsewhere. You are just getting it over a network. This philosophy, so this is a client. This philosophy is basically the cloud computing. Now, delivery model means what are the ways in which the cloud services can be delivered? What are the ways in which the cloud services can be delivered? It so we are simply stating right now cloud service. We're not diving into what kind of service. So this is about how many ways of delivery is there, how many types of services are there, right? So you can get, I agree that I as a client can get a cloud service from, let's say, a cloud provider like Azure over the network. That's fine. But the delivery that is happening from the client to me, this delivery, what are the modes of delivery, right? What are the modes of this delivery? For example, I'll give you an example. Okay, let us say that you want you want to eat, you know, in India we have this very famous pani puri golgappes, right? Golgappa. Now you want to have those. So you have, essentially you have two ways. One, this is your house. You get ready, go out of your house, go to that nearest pani puri stall, and ask for that pani puri. He'll basically give you a small I don't know what's that word in English for that. He'll give you some kind of small plate or something, right? And he'll start preparing that, and he'll start giving it to you on your plate. He'll start serving you, and one by one you can start eating and request for the next one. That is what would happen. This is one way. This is one way. This is one way to get pani puri. The other way would be, let's say you are in your house, you don't wish to get out, and so you opened your, let's say, Swiggy or Zomato, and you order pani puri. But this type of delivery is going to be different. Again, in both the cases, you are getting served with pani puri, but this way of delivery is different. This time, what this guy will do is this, like whoever is going to be the vendor from which you have opted for this pani puri, these people will actually, have one packet filled with only the shells, the second packet filled with only the spicy water, one packet filled with only the potato stuffing, right? And he will deliver this package to you. And now it's your responsibility to take out the shells, fill in with the potato stuff, again, pour in the spicy water, and then start eating. See, here, both the ways you are actually getting pani puri, just that the way of delivery is different in both the cases. Similarly, here in cloud service also, it's very important to note that yes, you are getting the cloud service from an external vendor, from an external platform. You are getting, but how is the delivery channel, right? That is pretty different. The mode of delivery is different. That's what is basically a delivery model, right? So when I say cloud service, it's a very broad word. Cloud service is a very broad word. There are so many types of services depending on what you want to use, right? So there are certain services which falls under infrastructure as a service, certain services which falls under platform as a service, certain services which falls under software as a service. Now let me explain each of them without causing any problem while trying to understand this. That's my promise. Okay. So first, let's start with infrastructure as a service. Let me explain this part with the help of a very simple example. Let's say there is a guy called Anish. Okay. There's a guy called Anish. Now, this guy wants to play, let's say, a game, a PC game. Let's say he wants to set up a PC game and he wants to play, like, let's say, again, I'm lost touch with all the games, but the last I played was Max Payne 3 back in when I was in college. So let's say this guy wants to play Max Payne 3. But the problem is, Anish has got a laptop. It's a very basic laptop. It has got around, let's say, 4 gigs of RAM. Very old laptop. This kind of configuration is actually not going to support the game that he wants to play, right? Um, so he has two options. Like he has got one fundamental option, which is to upgrade his current configuration, which is to go for a very high priced laptop. Let's say he wants to go for 16 gigs of RAM. Clearly a better upgraded version of the laptop. That is one option clearly that he has. But the question is that Anish is not in a financial capacity right now to go ahead and buy that, a fresh machine. So what additionally that he can do is he can, I mean, this laptop, this 4 GB laptop is still functional, so he could still use this laptop. Now he could just open the portal. He could go to any cloud portal, like let's say Azure portal. In Azure portal, he could create, if he has got a valid subscription, of course, he could create a virtual machine. Okay. Now, virtual machine, again, I'm trying to give a very simple example right now. That's why I'm giving the example of games and all. But in real time, this virtual machine is typically used as a deployment server. Okay. But right now, forget about deployment server. Right now, he has gone to Azure portal. He has got a subscription. He will create a virtual machine. Now, he could choose the size of that virtual machine. That means if he wants to have a 32 GB RAM virtual machine, he can have it. Now, once he gets that virtual machine, along with the virtual machine, he can also get a public IP address. Now, all he has to do is every single time he wants to play the game, he has to just open his laptop, connect a, do a remote desktop connection or SSH to this particular virtual machine. Let me change the color via this IP address that he has got. Now, using his own older machine, he can log into the virtual machine. Now, this virtual machine, remember, is running on the data center of Azure, Microsoft. It is this virtual machine has not been provisioned to him through his own infrastructure. This VM has been received by Anish via Microsoft data center, right? So in this case, this VM is actually um, is being provisioned from Microsoft's data center infrastructure. He is accessing this VM via his laptop. Now he can log into this VM, install the game, and start playing the game, enjoying the game. Because this time he has to install the game inside the VM, and VM is clearly of 32 gigs of RAM. So that's not going to be a system requirement problem. Again, you could argue, say that the game's quality could be compromised because even though the game has not been installed on this laptop, this game is installed on the VM, which is clearly 32 gigs of RAM. But the problem is that um, the quality of access, mm, a lot depends on the speed of the internet. If the internet speed of Anish is bad, then he will have a tough time experiencing a good quality game setup. So that's, yes, I agree, but let's imagine that that's not a internet is not a problem there. So this is just a very simple example of infrastructure as a service that I've given you. Now guys, if you've understood this point, try to think about it. In this case, he had to provision this virtual machine. He had to select which operating system this particular VM is going to support, whether it's going to support Ubuntu, it's going to support Windows. He had to choose the size, whether 16 gigs of RAM, 8 gigs of RAM, 32 gigs of RAM. He had to choose a lot of configuration like disk size, how many disks would be there, all of that, right? And then he manually had to install the game in this virtual machine. Basically, he got the infrastructure over the network, but he simply got the infrastructure. What he does with that infrastructure is completely Anish's responsibility. He has to log into it, and then he has to do installations. And if there's something that goes wrong with the game, let's say there's something that went wrong with the game DLLs got corrupt. In that case, Anish can't blame Microsoft for it. Microsoft will say, see, our responsibility is just to provide a VM. We have given you the infrastructure. Now, if something goes wrong inside that VM of your particular file, that is your responsibility. This kind of setup is actually called as infrastructure as a service. Again, we are not done with it. Okay. So let me just go back to this file and explain you. So cloud computing also offers virtual machines. Okay. If you don't know what's a VM, you can go ahead and Google it as well to get more understanding. But just know that VMs are simply remote servers. What is remote server? A server which is not exactly in your premises. It is remotely situated and you're just accessing that server over the web. So that is a remote server. Now Ashish wants to play a game that requires 32 gigs of RAM, but his laptop has 8 gigs of RAM. In this case, Ashish can create a virtual machine from the cloud portal and make sure that it's having 32 gigs of RAM and without even owning the hardware. Remember, in this case, he can create a VM from the cloud portal, which is this VM is going to have 32 gigs of RAM, but he's not actually owning that hardware having 32 gigs of RAM. He's renting it. He's going to get that server over the web, right? So without even owning the hardware, he's going to get a virtual machine having 32 gigs of RAM. He can just create a VM resource. All he has to do is he has to create a VM resource in Azure portal. We're particularly talking about Azure. That's why we're using the word. In AWS, it's called as EC2 instance. Okay. Now this VM will have some IP address, like I already discussed, and customer can connect to that VM from his own laptop, like I already discussed. Now this example was for game, but in real world, virtual machines are treated as deployment servers. Like I told you before also, I mean, see, there's no problem in you treating a VM for a game, but just know that normally virtual machines are very much used as a deployment server. Now, what do I mean by that? Deployment server. Let's say you want to deploy a front end website in production, back end in production, or database, want to host a database in production. So we generally deploy these databases back and front end in that virtual machine, and we call it as a production server or a deployment server. So these virtual machines are the same, like these are servers only. VMs are also servers, either call it deployment server or production server. But these VMs are generally used for that purpose, generally used. But again, feel free to use it for any purpose. It's just like, a regular computer, just like a regular operating system, Windows 10, 11, or Ubuntu. Like it completely depends on you. Okay. Now, let us say that Ashish wants to host a front end or a back end or a database. Let's say any Angular application is there, backend is in .NET, database, let's say SQL Server, and he can simply, if he wants to deploy the front end, the backend database, he can simply create a virtual machine, connect to this virtual machine via his own machine, and then deploy whatever workload he wants to deploy. See, if you look at it, it's one way, it's very good that you are getting one machine, very powerful machine. Whatever power capacity you want in this machine, you will get it through cloud. You don't need to have that kind of infrastructure. Still, you can enjoy that infrastructure. That's good thing. But you have to log in, and it is your responsibility to make sure if the front end is in Angular, make sure Angular SDK, Angular CLI, Node.js is installed, and then the front end is deployed. Again, you have to deploy the front end. It's your completely your responsibility. Similarly, backend, if it's in .NET, then .NET SDK has to be installed, and then .NET Web API has to be, published and deployed. Completely, it's going to be your job. Similarly, database, then SQL Server, SDK has to be installed, and then database has to be deployed. So my point is that you are getting the infrastructure that you wanted. Anish is getting the infrastructure that he wanted, but once he gets the infrastructure, that is all the job of the cloud provider is. Cloud provider will provide you the virtual machine or the infrastructure. Now it is Anish's. Okay, so we went with Anish, but here it's Ashish written. It's fine. So it's Ashish's responsibility to go ahead and log into this virtual machine, install the important SDKs, and then deploy the application files. Right. So what's the advantage of a VM? you will get a fresh remote machine, and now you are free to log into this VM and do anything. Install any software or runtime, you will never be limited. So basically, in short, flexibility is the advantage. Flexibility, flexibility is the advantage. Fantastic flexibility. You want to play a game, no problem, do it. Nobody's stopping you. You want to install front-end SDK, Angular, you want to install React, you want to install something else, no problem. It's like my machine, it's like my laptop right now. I can install whatever I want to write, given that there's no admin uh, privilege required. I can install anything. There's no limit to it. Similarly, VM is also like a machine only. It's a simple computer. You can install whatever you want to install. So flexibility is a great thing to enjoy here. But there is a disadvantage as well. Now, what is the disadvantage in the case of VM? Managing the VM becomes completely your responsibility. That means if there is a security compromise, again, you are responsible. If there is an update problem, let's say there is a particular updation, let's say right now it's a Windows server. Normally, deployment servers are used. They don't use Windows 10, 11. It's normally used for personal use. But for deployment servers, there's a particular server images like Windows Server 2019, Windows Server 2023. All of these are there. So let's say you want to update the Windows Server image. So all of those are completely your responsibility. If there's an operating system concern, it's your responsibility, right? So yes, you get the flexibility to install anything and everything, but you also are now responsible for anything that goes wrong in this VM. If tomorrow you say that my front end is not working, deployment file got corrupted, the backend, it's the IIS is crashing, the web server that is installed, let's say IIS or Tomcat or Nginx, that is crashing again, it's not Azure, Microsoft is not to be blamed for that. It is completely your responsibility what happens inside that VM, because you're taking the charge. Okay. So this kind of so again, VM is what ultimately? VM is nothing but a cloud service. So this kind of cloud service wherein you are getting um, the infrastructure, but then after a point, so I agree that you don't get to manage the data center will still be there with Microsoft. You don't have to manage the data center and make sure cooling is there in place, make sure network engineers are guarding, make sure there's no vulnerability attack happening at the data center. That is not your responsibility, I totally agree. But once you get that infrastructure, what is running inside that infra is completely your responsibility. Okay. So if inside that VM, if something is crashing, you're responsible. If there's an update problem, security problem, antivirus problem, anti-malware problem, all of that you are responsible. So that's just one way to deliver the service, right? So this is one kind of service called infrastructure as service. I believe we are good with that. Now let's move to the next service, which is platform as a service. Firstly, it's very important that you note that this is also called as a managed service. It's a very popular name. You will find this word called managed service. So just note that it is managed service. Ashish wants to deploy a backend written in .NET, but he does not want to manage the virtual machine. See, right now, I mean, up until now, when we were learning about infrastructure as a service, Ashish just wanted to deploy backend. Was he doing? He was basically creating a virtual machine. He was then logging inside that virtual machine. He was installing, let's say, .NET SDK, and then he was manually deploying the binaries. That's what he was doing. Now, Ashish still wants to do the same thing, but this time he doesn't want the burden of managing the VM. Because see, if he gets the VM, he has to manage the operating system, make sure that VM is not crashing, make sure that the deployment is a success, make sure that files are not corrupt, make sure that antivirus, malware, everything is in place. He doesn't want to take all of that headache. In this case, cloud providers say that, boss, if you don't want such kind of headache, we will give you a specialized managed service for your specific need. Mark my words very carefully, okay? I'm choosing my words very selectively. They are saying that if you don't want to manage the complete virtual machine, we are going to give you a specialized, dedicated, managed service. And we call it platform as a service. We call it platform as a service. Okay. Now, what is this platform as a service? For example, if he wants to deploy backend, you know that backend is ultimately an HTTP based resource. So there is going to be a particular service by Azure that is only going to support the deployment of backend and frontend. Or let's say just backend. Now this pass, so this particular service will be coming under pass. Why coming under pass? What is the advantage? The advantage is that if Ashish gets this kind of service, which is a pass service or a managed service, he doesn't have to bother about managing the complete virtual machine. The virtual machine, yes, there will still be a virtual machine. Yes. So even though it's going to be a pass, still there is going to be a virtual machine in the background. So ultimately, if he wants to deploy a .NET backend will still be deployed in a virtual machine. But the good part here is this virtual machine is not customer's headache. That means it's not Ashish's headache. Ashish will just say that, okay, I want to deploy .NET. Which version? Let's say .NET 6. Okay. Which operating system you want in the background? Let's say Windows. That's it. Just deploy that and we can just deploy. We will get that service. We can resource and we can deploy that. No need to bother about the virtual machine, log inside that virtual machine, install the SDK, make sure the deployment is success. All of that is not our concern. That is platform as a service, PaaS. See, I agree that this is looking very, I mean, if somebody doesn't have any experience, it's looking very theoretical as of now. But at this point, I don't want to go complete practical because as and when we start with Azure development, we will see everything in the most practical manner. At this moment, let's keep things at a very conceptual level. That's why I'm not, going and diving too much into the practicals. So just note that in platform as a service, there are dedicated services for a dedicated process. And you don't, customer doesn't need to bother about maintaining that infra, which is there in infrastructure as service. So see, same backend can be deployed in a virtual machine. Same backend can be deployed in a particular PaaS service. No problem. But it's the trade-off between luxury and flexibility. If you want maximum flexibility, go ahead with the virtual machine. You can do whatever you feel like doing. Nobody will stop you. But if you go with PaaS, if this PaaS is for in order to host the backend, then it will only host backend. You can't say that I also want a database hosted in the same PaaS. No, there's a different PaaS, different managed service for databases. Similarly, if you want Redis, again, there's a different Redis service, which is a different PaaS. If you want, let's say, storage, there's a different PaaS service for storage. See, it's for dedicated job. It's for dedicated particular thing that you want. You will get one particular SaaS, PaaS. But in virtual machine, infrastructure as service, you just get single VM. In the same VM, we can install, you can host the front end, you can host the back end, you can host the database, you can host the Redis, you can host the storage. Everything can be in one place. So yes, flexibility is, if that is your concern, go with a virtual machine. But these days, there's a great trend. PaaS is proving out to be a much better option actually. So if you want, you don't want to manage everything on your own. You feel like, okay, let's delegate this service to Microsoft only, and let's only enjoy so that we can focus on what's really important. In that case, you can go with the PaaS service. But remember, one PaaS service is only for one specific job. One PaaS service is only for one specific job. Okay. So let me just erase this and show you what I have written here. Each PaaS resource performs a dedicated job. Example, if there is a PaaS service to host backend, then it can't be used to host database. If a PaaS is for a database, then it can't host the backend. So it's like, I hope you're understanding the point. It's like Each PaaS service, platform as a service, or a managed service, does a dedicated job. Again, this people have this question that, okay, this is a PaaS I got. Will I be, so you're saying, so what I'm saying is there is in the background, there's still a virtual machine. People say, can I log into this background virtual machine? And the answer is a big no. You can't log into this virtual machine. Now that you have decided to delegate this activity to Microsoft, now Microsoft says completely just close your eyes and believe in me. I will not let you log into this VM and mess it up. So this background, yes, there will still be a background VM, and there's an abstraction layer of this UI that you can use to work with. But this VM will not be, you'll not be able to log into this VM and do anything, any installation or some anything. Okay. This VM will be completely abstracted from you. Okay. So just know that you can't log into this background VM. But if you want to go with infrastructure as service, you'll directly get the VM, but you will not get the luxury of Microsoft managing things for you. Everything becomes your responsibility. So I hope this these two concepts are clear. So that's what I'm saying. But a VM can be treated in any way if that you want. The same VM can host front end, back end database. So that's the difference. Okay. PaaS internally uses a virtual machine in the background, but a customer can't log into that virtual machine. So I hope whatever I have covered is actually written in the document, and now it's pretty much clear. Software as a service is something that you don't need to worry too much right now. Neither, it's going to be part of this Azure development journey. Just note that in software as a service, uh, it's like you don't manage anything. For example, Microsoft Dynamics, that is an example, or Microsoft Office. All of these are example of software as a service. In fact, Outlook, all of these are example of software as a service. You neither have to worry about a virtual machine in which it's going to be hosted, so you don't have to worry about how to manage the VM and completely take care of it. You don't need to worry about write the code for Outlook and then host it in a service that is gonna be using very minimal, that's gonna be consuming very less amount of your work, like pass. Like, see, even if you go with pass, see, even if you go with pass, I agree that they will give you a virtual machine that you don't have to manage, and you can deploy everything in that background VM. But ultimately, what you are deploying is you are writing the code of the application that you want to deploy to this VM. Code is not being written by Microsoft or somebody, right? But in software as a service, even the code is written by Microsoft. How they manage is their concern. Where they deploy is their concern. VM is their concern. So VM, how they manage the deployment, let's say any kind of they're using pass offering, they're directly using a VM, that is their concern. And the code also they are writing. Have you written the Outlook code? No, they are writing the Outlook code, and they are managing the deployment, and they're deploying it, and they're managing the resources then. So it's like software as a service is the last form. You can directly just consume it. Platform as a service, it's less responsibility, but then you don't get a lot of flexibility on that particular pass. But then, yes, you don't have to manage the complete VM. But in infrastructure as a service, you have to not just write the code, you have to not just deploy your application, but you have to manage the virtual machine also. So you see, it's like infrastructure as service, then platform as a service, then software as service. So in terms of ease of access, this is the best. The most difficult to manage, yes, this one, because you have to not just write the code, not just deploy, but also you would have to take care of the VM. But in platform as a service, you have to just write the code and focus on the code, simply deploy. The background VM will be completely Microsoft's responsibility. So I believe, this made sense, and you got to learn the basics. If you have been with me up until now, it means you've understood, all of that is making sense, and that is all that's required in this journey with Azure development. Because the 12 modules that I've discussed, like I told in the intro, that there are going to be 12 modules. In each of the modules, one by one, we're going to drill down on each of the managed service. So Azure development is not about understanding virtual machine, because in virtual machine, anything can be done manually. It's about understanding the managed services. For deploying HTTP workloads like backend, frontend, we have different service. For deploying database, we have different service. Deploying storage, we have different service. For in order to do something, let's say Redis is a different service. CDN, there's a different service. So it's like understanding each of the managed service. That's why I say it's very important before you move towards the journey of AZ-204 or Azure Development. It's very important that you understand what is the difference between PaaS and infrastructure as service, because AZ-204 is all about PaaS, because in each of the module we'll be dissecting each PaaS offering, like each managed service for each particular use case. Okay. So I hope it made sense up until now, and I hope to see you maybe in the next module as and when we start. Thanks.